Previously, we've covered the basic atomic model. Now we're going to talk about specifically electrons, because those are pretty important when it comes to biology. All right, so as we said before, that atoms, remember, atoms can take on, share, lose electrons. So sometimes electrons can, become part of an atom. Sometimes an atom will, lose an electron. And sometimes it can share an electron or several electrons. And this is something that is very important for biology. Now, the number of electrons an atom has helps determine how another atom interacts with it. All right, so, think about sodium and chlorine, right? Why does that form salt? Why does hydrogen and carbon form hydrocarbons, like lipids or carbohydrates? All right, all of these things are explained by the number of electrons that these atoms have in their outer shells. Okay, so it's very important to know how these electrons move. And does an atom want to share that electron? Or does it want to give up an electron? Or does it want to take on an electron? So electrons are going to move around the nuclei in predefined paths called orbitals. So here we have one proton, and we have a single electron moving around, and this pathway is an orbital. Okay? Here we have two electrons in one orbital, and it's going around in the same pathway around the nucleus. All right? Now, an orbital can have a maximum of 2 electrons. Okay? An orbital can be empty. An orbital can have 1 electron. An orbital can have 2 electrons. But past that, we cannot have any more electrons in these orbitals. So you might ask the question, how does an atom have all these electrons? Well, the answer is that it has multiple orbitals. And these orbitals then form what we call shells. So what's the take-home point here? That an atom has multiple orbitals surrounding it. Orbitals are, again, zones where an electron can exist. An orbital can have a maximum capacity of 2 electrons. And when more electrons are added, they go into different orbitals. All right, so here we have just a couple more models of atoms. And the point is that every orbital carries only 2 electrons. Do you see how the authors have diagrammed it here, where we have 2 electrons here, 2 electrons here, 2 electrons here, 2 electrons here, here, and here. So point is that electrons exist in orbitals, like a racetrack almost for electrons. And these orbitals can only hold 2 electrons. And as an atom becomes larger, it has more and more orbitals, and these orbitals are arranged in shells. So electrons and protons have the same size of charge, just opposite signs or opposite types. Remember we said electrons, we said were negatively charged, had a -1 charge. Protons have a +1 charge. Okay? So they're the same size, but opposite signs. Kind of like a yin and a yang type of thing going on here. And the charge of an atom is the number of protons minus the number of electrons. We'll do some more examples of that in a minute or two. Now, when the number of electrons and protons are not the same, you've got an ion. This semester we'll start saying ion on occasion in about a month or so. I'll start bringing the idea of what an ion is, okay, and how we look at that in biology. For example, calcium ions are very important when you start talking about how a muscle functions. Sodium and potassium ions are important when you start talking about how a neuron works. So you're going to hear this term ion many times this semester and next semester. And all an ion is an atom that has an unequal amount of electrons and protons. Okay, that's all it is. That's all an ion is. It is a charged atom because the number of electrons, which remember we said has a -1 charge, and the number of protons, which is a +1 charge, when these two charges do not equal, or the number of these are not equal, we have a ion. Now, ions can be either negative or positive. And I'm pretty sure you can kind of see what's going to be what here, right? We already said electrons have a -1 charge. Protons have a +1 charge. So if something has more electrons and protons, then it is negatively charged, right? It has more negatives and positives. The balance goes toward the negative. Conversely, sometimes an ion can have fewer electrons and protons, the second example, and that would make it positively charged. That the balancing between the negative and positive is not equal. There's more positive than negative, and we have a positively charged ion. Again, the charge of an ion equals the number of protons minus the number of electrons. Okay, so here we have something. I'm going to say that there are 11 protons in the center here. Okay? 11 protons in the center, 11 number of protons. How many electrons do we have? Electrons are going to be the yellow orbs. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 electrons. What charge is this atom? Well, 11 minus 11 equals 0, right? So this atom has no charge. If I said there's 11 protons, has 11 electrons, 11 minus 11 is 0, right? So this atom right here has no charge. Okay, so now let's talk about the charge of the atom. So I'm going to tell you that this atom has 11 protons in the center. So we have 11 right here. Okay, so we now want to know the number of electrons. The electrons are the gold-orange spheres. We count all those up, and we got 2, 4, 6, 8, 9, 10, 11. We've got 11 electrons. What's the charge of this atom? Well, 11 minus 11 is 0. Exactly. So the charge of this atom is 0 because the number of protons equals the number of electrons. So they kind of balance each other out. Now let's just say that this electron, remember we said electrons move? Well, let's just say this electron was lost, right? So we still have 11 protons in the center, and that electron is lost, and we get this species over here. We still have 11 protons in the center, but we lost an electron. So if we've lost an electron, let's redo that calculation at the top. Well, we have 11 protons. We've not lost any protons, but we have lost an electron. So we've gone from 11 electrons over here to how many? Well, we've gone to 11 to now 10. We have 10 electrons, so 11 minus 10 is what? +1. So this atom has a charge of +1. Because it has a charge, we call it an ion. So this is an ion because the number of protons in the center are not equal to the total number of electrons in the entire atom. This atom has more protons than electrons. It has more positive charges than negative charges. Therefore, it's a positively charged ion. Okay, let's do another example. Here we have 17 protons. So I'm going to put 17 in the center here. And we count the number of orange spheres surrounding that and all those orbitals. And we come up with the number 17 also. So here we have 17 protons and 17 electrons. 17 minus 17 equals 0, right? So the charge of this atom is 0 because the number of electrons balance with the number of protons. Okay, it's that perfect yin-yang thing going on, right? The number of positives, 17, balances with the number of negatives, 17. We get a charge of 0. Now previously, again, we said that electrons move, right? Sometimes an atom can take on an electron, sometimes it can lose an electron. Well, here what's happened is an electron has been acquired by this atom. So now we have 17 protons in the center, 17 protons in the center here. But the difference between what you see on the left and right is what on the left has gained an electron and become this. So over here we have 17 electrons, 17 protons on the left. On the right we have 17 protons, and if it gained an electron, how many electrons? 18, right? Because we've said that electrons can be lost, they can be gained, or they can be shared. Here's a situation where an atom has gained an electron. Okay? So let's do the math here. We have 17 protons, right? How many electrons do we have? 18. What is 17 minus 18? Well, it's -1, right? So 17 minus 18, do the math on that, you get -1. So what we have on the right, this purple diagram here, this is an ion. But what kind of ion is it? Is it a positive ion or a negative ion? Well, this is a negative ion. Why is it negative? Because it has more electrons than protons. The whole charge of this is a -1 because, the protons, the 17 protons in the nucleus balanced out with 17 electrons surrounding it, right? So all of those balanced. But what was the end product? Was there more electrons? Well, yes, there was. There was 18 electrons. We had one more negative electron than protons to counter it. Because of that electron, then we have to say that this atom has more negative than positive, and it has a -1 charge, and it's a ion. All right? Chlorine would be a good example of a negative ion.